Okay, so the second part of the video for 1.7 day 1, inverse functions and relations. So now we're going to look at some special types of functions, one-to-one functions. You should remember from the very first lesson that a function, if you have a function, every input, so that's every x value, has only one output. Every x value maps onto only one y value. And how we know that's true, the test for this is, if you have a graph, it's going to pass the vertical line test. Because when you draw a vertical line, what you're actually testing is an x value. You're getting x equals a number and trying it for every number you can possibly imagine. So you're drawing x equals a number. X equals would be a vertical line, and you're getting that vertical line and scanning across your graph. Now, one-to-one functions are very important. What's special about a one-to-one function is every output can only be generated by one input. So to test for this, we're testing y values. So we're testing lines where y equals a certain number, and we're trying it for every single different one. So what we're actually going to use is the horizontal line test. A one-to-one function is, what's important about them is when you get an output, only one input could have generated that. And it gets you some very special properties. So let's have a look at this graph here. And let's graph this and see what we get from this. So, oh, I've lost my fancy bits. They're going to disappear. Let's go down here. Yeah. So graph this. This is a parabola shifted up 3. So your vertex is going to be at 0, 3. And when you graph it, please, a bit of careful graphing. So there's your vertex. When you go 1, oh, that should be there. It's slightly out of position, this, isn't it? 2 is 4, 3 across would be 9. Okay, so I've got a perfect parabola there. And let's graph its inverse. Let's try it by graphing techniques, not with algebra, by graphing. So if we have the point there, 0, 3, we're going to plot the point 3, 0. If we have the point 1, 4, we're going to graph the point 4, 1. Okay, so graph all those in, and you should get this shape. So f of x was a function, but when we graphed the inverse of it by getting every single point and switching the x and y coordinates, then what we end up with is this, and this thing fails the vertical line test. So this that I've just graphed here is not a function. Okay, so it's not the inverse function of x. Because it's not a function, we can't use function notation to describe this. And that becomes really important, not so much now. We're going to do a very simple test for whether something's got an inverse function at the moment. But later on in pre-cal, this is going to become really important that you understand how we have to cope with this. Because we can only at this point really deal with functions. There's other things we can graph. We'll get onto this another time. But when we're solving math equations, we need inverse functions to solve things. So why did this happen? It happened because this failed the horizontal line test. F of x was a function, but it's not one-to-one. 2 x values, say if we got this y value, let's use this one here. This y value here could have come from this x value down here, or from this x value down here. This is actually a 2-to-1 function. 2 inputs are producing the same output. And because it's not one-to-one, when we graphed its inverse, it turned out to not be an inverse function. So what can we do about this? First of all, clear all this rubbish off the graph. I don't want all that in my way. I'll just delete all that off, okay? What we're going to do is highlight just this side. If we got f of x and we ignored all of this and we just used that side, when we reflected this side of the line y equals x, we'd end up with just this part. Now we've actually got a function. What we had to do there was we restricted the domain of our function that wasn't one-to-one. We restricted it to a piece that was one-to-one, and then it has an inverse. And that's going to become very, very important when we move on to trigonometry, that you understand why we have to restrict the domain of this to end up with a function, because when we end up with a function, we can solve it and get an answer, and then we can get beyond that answer, because that answer, say you were trying to find, this you can see now, it's a square root function sort of moved over a bit. If you were trying to find the square root of 4 on a calculator, your calculator's only going to give you the answer 2. But I hope you guys know that there are actually 2 square roots. And so we're going to get one answer, and then we're going to use our intelligence to work out what other answers would also exist. Don't have to do that quite yet, don't worry. That's when we get on to trig. So let's move on to our next slide. So, but this is important to remember. Oh, this is going to go crazy. I'm going to have to stop this in a minute. A function must be one-to-one for its inverse to be a function. So we get questions like this. Do these functions have an inverse? What we're actually asking you there, I might actually type this, it'd be faster than saying it. Oh, maybe I even have it hidden. Did I hide it? No, I didn't prepare it earlier. Never mind. Okay. So these are only functions. What this question is saying is, do these functions have an inverse? We're actually asking you the question, are they one-to-one? And how would we know if they were one-to-one? By using not the vertical line test. The vertical line test you've been using for years. The vertical line test just checks they're a function, and they are all functions. But if they're one-to-one, they're going to pass the horizontal line test. So let's get a horizontal line, and let's check them. So this one. Oh, yes, it's doing wonderfully, wonderfully. Oops, no, it's suddenly gone 3-to-1. Yeah, and then it's okay again. So this one, does this function have an inverse that's a function? The answer is no. What about this one? Next one. Here we have, it's passing, it's passing, it's passing. Ooh, looks a little dodgy around there. Now that is actually still decreasing all the way. It just looks as though it's almost perfectly horizontal, but it's not. It's still decreasing as we're going across it, so that's fine. So this one, the answer is yes, and same for this one. The answer would be yes. Okay? Right. And for today's closing task, here you go, have some fun. Right? Find the inverse of this. Now, deliberately, I want you to think about this one because the algebra behind this one is much more tricky. Remember how you start. You replace this with y, and then you switch over all your x's and y's. So, I've done the first step for you. And now you have the joy and delight of trying to solve this for y. I'll give you a hint. To solve for y, it would really be helpful if you could get rid of all the ugly bits in the equation and just end up with a whole bunch of terms with or without y's in them. Get everything just simple things where you're adding or subtracting. Nothing else really apart from adding or subtracting, quite simple little terms. Then you can put, oh gosh, all my phones are going today. Then you can put all the terms with y on one side and all the terms without y on the other, and see if you can simplify from there. Off you go. And here is your answer. Oh, move me out of the way. Okay. So first of all, you want to get rid of this dividing by multiplying both sides by y minus 7. Oh, why does that say x? That should say y. Look at that, there's an error. We've multiplied this y minus 7 here up there. Never noticed that before. So now we've got x times y minus x7x equals 5y plus 1. So we distributed the x's there. Now, remember we want all the terms with a y on them on one side. So I'm going to subtract minus 5y to both sides. That's this guy here. I got that guy and subtracted him to this side. And I don't want this because it hasn't got any y's in it. So I'm going to add 7x the other side, and that's where this 7x over here comes from. So I isolated all of my terms with y on them on one side of the equals and moved everything else on the other side. Now, look, you've got x times y and minus 5 times y. You've got a GCF, factor out the y. which would leave you with dividing out those y's, be left with x minus 5. And now it's really simple. Now you just have to cancel out that multiplication with division. Yay! And you're done. Okay.